Jon Corbett will be presenting, Jon Corbett, excuse me, will be presenting Ancestral Code and Indigenous Computing Framework. So welcome, Jon.
Yeah, hi. Tansei Jon Corbett. Nehiyawewin. Namosampan, Egwa Nokampan, Winnipeke, Osisik Ochi Wiwau. My grandparents were originally from Winnipegosis in Manitoba in Canada. Amiskwachi Waskaiganok Wachinia. I'm originally from Edmonton, Alberta, and I currently live in the Okanagan in Kelowna, British Columbia. I will be talking today about my project, I guess, that I call Ancestral Code. What Ancestral Code is a platform for programming using Cree language, nehiyawewin, and specifically Plains Cree Y dialect. And so this is just a quick map that kind of shows you the progression of where my grandparents came for that red dot to where I was born in Edmonton, which is the blue dot, and where I currently live is in that little purple area down in the southern part of British Columbia. In this talk, I'm going to give a brief overview. It's more of a brief story of my media artwork and the purpose of this platform. And really, I took a holistic view that actually came out of earlier work. And then I'll try and wrap it all up, and we'll try and do this all in 20 minutes. So going back probably 6-7 years ago, I was doing an MFA at the University of British Columbia, and I was doing beadwork, trying to reconnect my traditional Indigenous heritage with giving it or passing it on to my kids, my children. And so I decided to do a beaded portrait of each of my children. And through that process, I thought it was interesting that my grandparents, who are not around anymore, didn't get to see what I've accomplished with the computer. And so I thought it would be interesting to kind of reverse that time role and represent them in digitally beaded portraits. So I wrote a computer program that created similar portraits, just digitally. I didn't actually bead them with beads. I made digital beads and programmed them into computer. So my ancestry, I illustrated in this digital format, and my children, I did in this very physical format. And it was through that I realized that one of the things I would have loved to have done is write my code in such a way that it reflected that Indigenous heritage. So being able to write it in Cree, and I didn't know really any Cree at the time other than a few small words. But one of the things that really struck me was not just the fact that my language of choice, which was Java, it's all in English, and even in using Cree, if I wanted to use syllabics, I can't, because the platform I was using to program in doesn't accept non-Latin characters. So I need a whole new platform in order, if I wanted to use Cree syllabics in order to render or write code in Cree. The other thing I noticed was this format of English within code being representative of the language of the computer. So I actually have to speak the language of the computer in order to tell it, about what I want it to do, what I want it to accomplish. And what I wanted to accomplish was beading. I wanted it to bead, but I wanted it to bead in such a way that it was a reflection of how I actually did it. And here's an example of what I did. Is my original code, which was just a simple for next loop, would have bead, or would place a bead on your screen from left to right. Then it would drop to the next row, go left to right, drop to the next row, left to right, and so on. I would completely do that process over and over again. But my physical beading, as you can see in that little image from the back of my son Lucas, my thread drops down and actually goes, so it goes from left to right, and then it drops down and goes right back to the left, drops down, goes from left back to right. So I rewrote my code to be a reflection of that. And It was then that I kind of realized that the code is inefficient, but that's not the purpose. The purpose of the code is to be reflective of my cultural heritage. And so this is just a quick snapshot from the CBC website that shows this animation of, I actually made it into videos where it shows my portraits transitioning from generation to generation in this digital model. And I replaced that grid work with a spiral, which was more reflective of Indigenous perspectives. And here's a close-up of my grandmother. Now this work, I converted it from, it's completely generative, so it's written and runs in real time. And I converted it into a video so I could showcase it at in the gallery setting, and it was at the Smithsonian Gallery for about a year from 2017 to 2019. And I recently just sold that video work to the Indigenous Art Archives here in Canada. So I'm very happy and fortunate to be a part of this Indigenous art collective, I guess. But I'm trying now to focus solely on digital work. So what came out of that was recognizing all of these deficiencies in technology that were not in line with my Indigenous teachings and epistemologies. And I decided to take on a greater task of looking at technology in a very holistic manner and looking at all of the points that I can touch to indigenize or decolonize those those things. And what I ended up with was this Indigenous Computing Framework or Indigenous Computing Platform that encompasses all of those things. So it uses nehiyawewin epistemologies and ontologies to inform the design of the hardware, the software, the mechanics of how that is all done. And I've done a lot of this work with special thanks to the University nehiyawewin miyāhkasike Blue Quills in St. Paul, Alberta, as well as some work I've done with Little Red River Cree Nation and the Little Red River Board of Education in High Level, Alberta. So collectively, this whole platform actually consists of two things. There's a hardware section and a software section, where the software section, which I'll touch on in more detail, and is really the focus of what my talk is today, incorporates the language and the code as a programming language. These other two I'm just going to draw on or touch on briefly. But this whole environment includes these indigenously formed components with an underlying framework that's focused on Indigenous understandings in not the Western computing architecture. So the way the computer was designed is not how I'm actually approaching it. I'm trying to rewrite the philosophy behind computing, computational systems and architecture with it. So as I mentioned, this holistic view is really a framework that surrounds the hardware and the software. And I'm just going to jump right in. I use Indigenous theory that's multi-layered, and I embrace, so nehiyaw, for those of you that don't know, nehiyaw in our language represents the four-bodied. We are four-bodied people or four-spirited people. And that reflects the spiritual, emotional, mental, and physical elements of being. And it is those four components, I think, that I'm trying to imbue into the computer and make it understand those four elements. And it's not just a matter of physical versus mental, so the body and mind. It also needs to include spiritual and emotional. And then my challenge, how do I digitally represent those ideas? I also view programming and this framework model in a very storytelling idea. So I look at the computing framework as a story, not as a list of terms and descriptions that tell you how the framework is to be applied, but it appears more as a story. And finally, within that, something I call indigenization, which is just taking, it's a portmanteau of indigenous and digitalization, and putting those two things together. Not to be confused with indigitization, which would be, for me, the indigenous digitalization of existing corpus material, or audio, video, text, etc. But at the heart, if you ask nearly any Indigenous speaker about their heritage language, for us, the language it comes from the land and it is ceremony. And if that is true, then computer programming, because you're using the language in the computer programming sense, it too is ceremony. And likewise, it's medicine, right? So when we use our language as ways to express ourselves, it is medicine. And so taking these kinds of concepts and understanding that when I do computer programming, if I'm going to do it with my ancestral language, that it is a form of ceremony and it is a form of medicine. And that's where this induction of spirituality and emotion can be applied to the machine from an Indigenous perspective. So the hardware design, my first task was, how do I get these items into the system? If I want to type in Cree syllabics, how do I do that? And now there are a number of solutions out there that give you mappings for your keyboard that involve, usually taping down or just understanding where those syllabics exist on the existing keyboard. And I didn't really care for that idea. If I wanted to be true to my language and true to my culture, we quite often use this star diagram as a teaching aid when teachers are teaching syllabics. And this is how one of the ways I learned was memorizing my syllabic charts off of the star chart. And now there's deeper meanings and cosmological concerns related to this chart. But I thought, if we had a keyboard, a physical keyboard based on this design, I try to envision what that would look like. So I mocked one up. And then I printed this off at real size just to get a sense of how big it was, where my fingers would move, how easy is it to type certain words. And this kind of cycles back to that idea of efficiency. I wasn't overly concerned with how efficient it was. I was concerned with how culturally attached to this as a design or as an aesthetical relationship, right, to my culture. I'm using culture as an interface to the computer. And it was partly there, but then I reformatted those keys because the square keys, again, I was using square keys because that's what was available. If I could make my own keys, what would I do? And when I put them into this format and started rounding the keys to make them, kind of closer together, you realize that star chart isn't a square, it's a circle, right? And it's representative of those four elements of being Nehiyaw. So this is my version 2 keyboard that I mocked up. And I took it a step further because this is in production. Well, I'll say production right now. I have the keys being 3D printed, and I just need a way to run them. So I need obviously a circuit board, which is the third part. And then this is where things get really interesting. The syllabic star chart is based, if you're sitting, because you sit in ceremony, you sit facing south. So the east door is to your left. So if you position yourself on the screen and you're facing south, and south then becomes the top of your screen. This is how I was taught about my star chart. East then is to the left. And that's why this microprocessor is on the left, because the microprocessor is where the knowledge comes from. And that is within our culture, that's where all the knowledge comes from, the east, from the sun. And usually your TP is facing east, so that all of that knowledge comes in through the gate. And you face south during ceremony. And so I situated that within this board. And I called it my drum board because the drum board or a drum, it has a sound, right? And that tappity sound of you finger clicking on the keyboard to me represents this artificial drum of the circuit board and the keyboards that or the keys that are going to sit on top of it. I also learned that, or I applied my, I don't know much about circuitry, but I designed the circuit board. You try to be efficient with your circuits, trying to make the path to the circuit board or to the microcontroller as short as possible. I don't care if it's short or not. What I'm concerned with is the path that it takes. So in this case, it's actually, I think, upside down, but it goes in a counterclockwise area, but internally it goes clockwise. And that just represents the path that we follow when we enter a sharing circle. We enter from the east. We walk, in my culture, I walk clockwise, and then I take my seat. And so that is the keyboard part of it. So taking those same ideas and then applying those to the design, now that I can put the syllabics into the computer, I need to know or understand the software aspects. What is the software actually doing for me? And in this case, it's not just a matter of what I wanted to do is capture a story and display the story as an animation. But in doing that, ultimately what's happening is you're storing a audio recording usually. And if there's a transcription, I wanted that transcription to be the code. I wanted that transcribed story to become a part of the actual program itself. And in doing that, you actually end up archiving it, right? So it becomes part of the program, which is actually just a form of digital archiving. And I wanted it to mediate that practice of oral transmission of knowledge. As well, computer programming to youth is extremely desirable to a lot, and it's very appealing, right? Because you get to interact with technology in order to accomplish a task. So doing it in your ancestral language, I'm hoping makes it even more exciting. This is the first prototype. I used C# programming to kind of mimic the Cree sharp, which is what I called it. And it's just a merging of the two ideas. So being able to use Cree syllabics in a programming environment, what would that look like? And this is my mock-up of what that kind of looks like. This is its current version. And what I've ended up going with is a model where the transcribed story exists on the left, which is east, because in that story is the knowledge that is feeding the code to the left, or to the right, sorry. And my coding window, I tag it. I don't want to interrupt the story, because the story, as transcribed or told by a storyteller, that's, the purpose is to maintain it and keep it. So I wanted to be able to capture that. And instead, what I do is I insert these little feather markers, and you can see that in this diagram. Right here, for example, this little gray feather. Colors are up to you as a controller to insert. When they're collapsed, like this yellow one, it just highlights that at this particular point, there's a section of code that would appear in this window to the right. And you'll execute that code when you hit that port in the story. This story here that's on the screen is actually from Solomon Rat, and it's the story of the miyāhkasike and the chickadees. And it is timed according to the telling of his story. And so it's still a work in progress, but as he tells the story, these markers happen at very specific times in the telling. And even because I can read a lot faster than he tells it, this transcription, you apply the length of the audio to this, and that applies the timing to the ultimate video that is, or the animation that's put out at the end. And I have a quick example. Let's see here. Oops, did I miss one? Oh yeah. So this, if you look on the right, everything is in syllabics. I do have an SRO converter, if you're not as familiar with your syllabics, and that's this version here. And now I have, here's a quick video, 30 seconds long, of what happens. You'll also notice that the beginning, there is no audio to this video, by the way. This opening smudge is actually a programmatic device. This the smudge itself, that smoke is computer generated at the time you run it. It lasts for 15 seconds, and it's a way of getting the computer ready for the story that's to be told, right? And so applying that spiritual understanding of what a smudge actually is to the story. And I think that's about it. So this is my quick animation of Wazagachuk walking along the path before he meets the chickadees. And that's as far as the code actually I have written. That's as far as it goes. And I know I'm getting close on time here. So just as I conclude, what I'm doing is braiding a lot of these worldviews, and I look at the behaviors, beliefs, processes as an Indigenous person, and I like to see where they intersect with the machine. And then I just deconstruct that machine's understanding of, or our understanding of that machine, reformat it and reconstruct it to be or come from that nehiyaw perspective. And I want the machine to be simulating and reflecting as much of our physical, spiritual, emotional, our 4 points of being within the program and within the actual architecture of the computer itself. Just to kind of wrap everything up here, I'm digitally encoding or providing a foundation where using that Indigenous programming language, and in my case, it's Cree, it provides a way of encoding it digitally because it's a program. It archives it. It's a program that can be opened and viewed by people who have access to that platform. Gives communities the control to protect and share their knowledge, because there are ways to mark up that storytelling program to not display or not play audio during those segments that are protected by the community. But it still maintains the archive of the entire story from the storyteller, which I think is extremely important. I believe it's an innovative way for the revitalization of languages, because you find, again, computer programming is interesting and intriguing. So, hi. And we can go to questions. So I appreciate everybody's attention. Thank you.
Yeah, let's thank our speaker for such an innovative project. That's really a lot to think about. I wish we had a lot of time to discuss this. Unfortunately, we only have 5 minutes for questions, so we're gonna have to pack them in, I think. The first one comes from Eddie Antonio Santos. Eddie, would you like to ask your question directly?
Sure.
Oh, I see it was a direct message. I'm sorry. Let the cat out the bag. Excuse me.
That's okay. Can you hear me?
Yes.
Okay, excellent. So for the speaker, maybe I ask two questions, but what is like kind of the plan, the timeline to get these tools to like nehiyawewin children, Squesis, Napesis, and the nehiyawewin in general?
My plan, I'm right at the tail end of my PhD, and so this is all getting put into my dissertation. My plan is to hopefully by the end of the year actually be able to workshop the programming language where I can go to communities, show them how it works, and just let them play. The keyboards are in production right now. Being assembled for a couple workshops I have coming up this month. Imminent, I guess, within the year for sure. It's one of the great things about COVID is I've had a lot of time to work on this. So soon is what I'm hoping.
All right, we've got another question from Rolando. Rolando, you want to go ahead and ask directly, or do you want me to read it?
Let me see. Can you hear me?
Yeah.
Yes.
Yes. Thank you so much for the presentation. I mean, you already told us that you're building the hardware as well. Like, could you tell us more about the hardware? Like, how does what kind of base hardware are you using for it? Is this programming language like a more high-level thing that you then interpret into compiler and send it to existing chips? I just would like to know a little bit more about the hardware implementation. And also, this is really creative. Thanks for your work.
Thanks. The hardware is, so like I said, I'm building the circuit boards myself. They're using a Teensy 2++ microcontroller, and then 3D right now 3D printed keys. But I'm going to hopefully get really good models that I can do injection molded keys and actually produce. I have a lot of communities right now that want a version of that star chart keyboard. I have like 3 other keyboards too. Like I have a standard keyboard because I did a syllabic analysis on a corpus of Bible passages to create a better layout pattern for the syllabics on a keyboard. You know, we have QWERTY for a reason. It's not the most efficient. Colmac or Dvorak is probably more efficient, but I went with a Colmac version keyboard and I remapped them to the syllabics that are most commonly used. So syllabics that are very low on the usage scale are in those, you know, X and Z positions. And it's been more interesting that way. And then as far as the programming language itself, I'm not sure where to place it in terms of high level, but yes, it actually occurs as a story. You actually tell a story in code that gets translated into I have a C# library that I've written that takes it and translates it into all the, you know, the actual activity that you see on the screen. So that little animation of Wizagachuk walking is all handled by this library I have in the back end to kind of keep that off the plates of the programmer, right? The intent of the system is to be a storytelling mechanism, and that's yeah. Hopefully that answers most of it.
Okay, Remo, I think your hand went up next.
Thank you. Thank you for the talk. I gotta say I'm really impressed. This is kind of a work of art, not gonna lie. And I'm amazed that you put this all together by yourself because it requires specialized knowledge in a lot of different domains. So that is really impressive. I don't know, I have a lot of questions, but I think something that kind of interests me right now is, so as far as I understand, that the aim is kind of to make this sort of an Indigenous project in all of its aspects, right? And from sort of the way programming languages that I know work, they're all kind of based on, you know, your bread and butter is your for loops, your if conditions, your while loops, right? And these are all kind of sort of, I guess you could call them Western logic concepts. I'm not even sure if I want to commit to that, right? But I think there's like a world where you could argue, oh, this is kind of Western cultural concepts almost. So I'm wondering if the programming language you're building is departing from that in some way as like a conscious effort, or are you keeping those concepts because they're kind of handy, I guess, in the context?
I don't know much time we have left exactly, but I do have an interview with Daniel Temkin at esoteric.codes that it kind of explains that a little bit more in depth, where I actually give a breakdown of keywords and reserved words and how they're put together, because I do use morphemic construction as well. So taking Cree morphemes and using, for example, if I have a variable called a Tim, so my dog, I can make that dog bigger by adding Mista to the beginning of it, which is like saying, you know, x equals x plus 1. Or I can add osis to the end at the end as a suffix and create achemosis, which is x equals, or you know, x is equal to x minus 1. I can do the same. I can actually morpheme them together and say Mista timosis, which is x equals x plus 1 minus 1, which doesn't result in anything, but you can do that, right? The language lets you do it that way. So yeah, I check out esoteric.codes. It should answer some of those. So.
Okay, I just want to hit pause for a second. We're out of time for this session, but Jon, if you're willing to stick around for a few minutes, we're leading into lunch now. I know there are some other questions, so if you're willing to stick around for another 5 minutes or so, that'd be appreciated.
Absolutely.
But before we go to lunch, I just wanted to thank everyone for attending this special session, and again, thank all of our speakers. I hope you'll join me in thanking them. So everyone is free to go to lunch if you'd like. If you have some other questions for Jon, you can stick around. So
yeah, I just want to say that if we're meeting persons, this is something that I find Hello, can you hear me?
Yeah, someone
Yeah,
needs to be
Wilson.
muted, I think.
I
I'm trying to
think
figure
Wilson,
out.
I think it's Wilson. Do you have
Yeah, I
another
have my
talk running?
background. Just, yeah.
Ah,
You'll have to
he's
mute that.
existing in multiple worlds.
Yeah.
Yeah.
So yeah, I just want to say that thank you, the presenters and the attendees. And if we are in person, I would say I would be paying you for your lunch, but oh well. I'm sure you have something delicious at home.
All right, thanks everyone. So we can continue the discussion with Jon, and forgive me, I think I lost the order. I know I saw John Powell's hand up as well as Eddie's. His was up. Yeah, I think it just went auto down. So Eddie, if you had a follow-up question, I think.
Sure. I have tons of different questions. I'm very much interested in nehiyawewin and computers and the intersection. A thing that I think would be, I don't know, maybe this is maybe not like going into like the ceremonial part of it, but I was wondering if you thought of making like a translation for, say, Scratch, because Scratch is really easy to teach to kids. I've taught it to like kids before, and you can put it in syllabics. You can put sakapekana in it. So I was wondering if that was like a thing, or if, I don't know.
I did look at a number of different avenues I could take. I originally started writing the language in Go because a lot of it comes down to material I have access to. I've never written a computer language before. I've only used them. So, and a lot of those things that came across in the previous question about we have these things that we typically apply, like variables and arrays and these various components. So I was looking at a way of representing this in the Microsoft Small Basic, using that same kind of idea, being able to create libraries so that you can use Small Basic to kind of do the same things, doing it in Scratch. A lot of it involves me relearning or learning another. Like now, I think I'm probably fluent in about 14 or 15 different programming languages, so I can easily adapt, and those are always possibilities. So I because of the structure of the IDE that I'm developing, I went with C# because that was the fastest thing I could get it out with. But I'm always open to side projects and finding other opportunities where this model fits. So, yeah. Yeah.
Jon Powell, I think you're next.
Okay, let me lower my hand. Jon, this was very fascinating. I think I'm among many in here who are just totally inspired by the work you're doing. Thank you for that. Comment then question. One of the things you were mentioning is you're like, well, at the end of the day, you're not so, like, for example, with the keyboard, you're not so tremendously worried about the efficiency, but representing Cree worldview. But when I was looking at sort of the ergonomics of the keyboard, I couldn't help but think, this is a hell of a lot more efficient than what we use, for our English keyboard, right? I can envision you using this keyboard with just a single hand, which is ideal for, the fingers being elongated and everything, for being able to get all the different keys. Who knows what sorts of implications it might have for carpal tunnel syndrome? Who knows what, right? So that's my first comment. So I think it might actually be more efficient, even though that's not necessarily your aim, which tells us a lot about Indigenous worldviews, right? But my question is, one of the things I'm thinking about is that there's going to be a lot of people who are interested in being able to have such a keyboard, right? Out in Cree country, and maybe even beyond in some of the other languages which have, similar orthography, similar scripts. I know you're still sort of prototyping or printing the keys and everything. Have you taken it a single step further, like by procuring a quote maybe on a couple thousand of these, to see how much they run? Because I think one of the things I've heard, like, for example, Cherokee keyboards can kind of run a little bit expensive because everything has to be retooled. Do you have any sense? Have you gone through that process yet?
Kind of. I did some rudimentary calculations because I do have a group in Little Red in high level are looking to, they want, the computer lab, 30 computers to have one of these keyboards, and they have 4 or 5 schools. So I'm looking at 100 keyboards just for them. And so I did some quick math, if I was to make these on my own, the circuit boards are easy enough because I can have those printed in China for, it was $50 for 5. So I had the circuit boards made, and even with shipping, I think it came up to $88 Canadian. So the circuit boards are cheap. The TNC2 microcontrollers were expensive. They were about $20. And I'm using Cherry MX and Gatoron switches, which run anywhere from 40 to 50 cents a piece. And so a keyboard, my cost on a keyboard, just assembling it by hand, is running up in the $150. So to make them feasible, for schools, it's going to be a chunk of change. Now, a lot of the schools that I'm dealing with, they're going to try to get a grant or something to help cover that cost, which is good. And those would be the kind of, I guess, the first run, that first iteration. But to your point of, producing 1,000, because once it gets out and they're actually live and being used, I think, trying to find a model that will decrease that production and make them more affordable for the average, language user who's just trying to learn their language and maybe at home, right? Having the tools necessary at an affordable price is going to be super important. So I haven't looked at larger numbers, and but that is definitely on my radar for sure.
Thank you.
Yeah. Maybe I'm next. Or wait, there's something in the chat here. Luxury switches. That was the comment.
Yes.
Yeah. So I was going to ask something else, but since you brought this up, I guess there's sort of two things here: getting it out affordably, but also maybe it's a learning opportunity, sort of hybrid of STEM, cultural aspect, right? So are you considering assembling the keyboards as a sort of a workshop, like teaching kids or anyone really from the community how to build a computer?
I am, as a matter of fact.
That'd be very cool.
It is within the next couple of weeks, I hope anyway. I'm just waiting for some feedback now with our provincial lockdowns happening. Mm-hmm. There's a couple schools in Saskatchewan that I'm trying to engage with to do a Lego workshop. So I have a whole bunch of Lego tiles with syllabics engraved on top, and I'm going to give them a Lego plate and say, you make your own keyboard. Where would you put the keys? I want to know where and I'm interested in those early language learners, right? Grade 1s through 1 through 4, 1 through 5. I want to know where they would put the keys, and are they going to mimic our Western keyboards, or are they going to use the star chart, or are they going to do something completely different? And that's, I'm definitely looking at that, and that's going to happen hopefully this month. I'm super excited for that. And then I'll carry that over, obviously, into the prototyping phase and get actual keyboards made like them.
Very exciting. If I ask one follow-up, so you'd mentioned C# a couple of times, so I'm assuming you're using parser combinators, not a parser generator library for the language, or for the
kind of yes, kind of no.
Okay.
It's all handwritten, really.
Oh, okay, really?
Or I'm parsing apart, and it's really hard because the morphemic construction is throwing a wrench into things.
I see.
So being able to pick apart the intended message when they're trying to, for example, my increase in size or decrease in size, knowing that syllabic or that syllable is actually doing the action, that's where it's getting a little sticky. And so because of the way you have to parse the language, I have to do it by hand. It's very hard to rely on those external libraries for that.
Right. So you couldn't use something like Antler because so much of this is context sensitive, I guess.
Yeah, exactly.
Okay. Well, it's a very exciting problem. That's fascinating talk.
I think I was overly ambitious when I applied for my PhD to do this, but I'm getting too close to the end, so I'll be happy when it's over. but not over, right? Because it'll continue.